Greetings, life forms. My name is Flux, and today we're going to be reacting to some Save Frank. This one is about bees. I said in the previous video how I view insects as like little organic mechs, and this one, this one is along that line as well. It's bees, like robot hive, like kind of like robot hive mind or something, like Ultron, except bees. Anyway, I'm so excited about this one. I followed Zay Frank for years now, and I haven't been watching him lately, but I am gonna watch him now. Hey, let's start without further ado. Okay, start.
The nest of the honeybee is a bit, well, I'll say it, anal. And I don't mean because of all the holes. I just mean it's a little too perfect. These sheets of honeycomb are used to raise babies and to store honey and pollen. And this comb is made from a series of hexagonal cells. And this shape, the hexagon, turns out to be quite special. To make these cells, honeybees use wax, which they secrete from their own tum-tum areas. I mean, that alone, you try building something with your secretions. But to make a pound of wax, you need the nectar from about 2 million flowers. Then you process that into about 7 pounds of honey, and then you get your secretions. It's a real bitch. So when you build with wax, you want to make something as strong as possible using the least amount of wax you can. Now, bee babies are sort of shaped like a tube, and they can curl up around too, so they fit quite well in a circle. But if you put a bunch of circles next to each other, there's a lot of gaps, and you don't share much material between cells. Not great for conserving your building material. To save some wax by sharing walls, what you want is a shape that tessellates, fits together perfectly when tiled. Now, in terms of simple shapes that tessellate, you got the triangle, but now you're building more than you have to with a lot of extra space around the larvae. Next would be the square, but you run into a similar problem. And then you come to the hexagon. And you can see just how much of an upgrade that is. Each cell shares walls on all sides with very little wasted space inside. But why stop there? The bottoms of these hexagonal cells aren't flat, but instead are a kind of cup made of 3 diamond shapes. What this means is that when you put 3 cells together and then flip them over, you can see that between them you form the bottom shape for a cell on the other side. So now you're sharing material there too. This winds up being one of the most efficient configurations, creating something that's both strong, but that also maximizes the amount of cells you can make with your materials. Now, I said one of the most efficient configurations, because some math hippie found an even more efficient way of doing it, by changing the shape of the base and how they're aligned back to back. Probably felt quite superior to the bees until they found that some bees make that shape too. Now let's hold on a second. It took me several hours to make this piece of crap, and I had a ruler and a compass. And meanwhile, these honeybees can build mathematical perfection, often in total darkness. And you know who they're working with? Their own family. You can imagine the arguments. And if they screw up and the thing falls apart, they lose like generations. And what's even crazier is that paper wasps independently evolved the ability to build something similar, except not out of body wax, but rather chewed up bits of wood pulp. Now, to get a sense of how this came to be, get it? It's worth going over a history of their approach to childcare. Now, bees evolved from wasps, but before bees existed, the wasps that were around could give a shit about changing diapers. They looked a lot like these
wasps.
That tube in the
Exit is first. What is that?
Rather a sort of drill/baby delivery system. These ones would find insect larvae, often hidden in plants. Their version of parenting was to drill down, lay an egg on that larva, and then leave. When the baby hatches, it eats the larva, but otherwise has to fend for itself. Now, if you have children and you're thinking they're onto something, well, the wasps would agree, because the vast majority still do this today. Boo. Now, there was a group of wasps whose ovipositors evolved into a stinger that could deliver venom. Good for defense, but also allowed them to hunt insects and then paralyze them, keeping them alive long enough to stuff them in a hole somewhere, lay an egg on them, seal up the hole, and then leave. But back then, this was sort of like helicopter parenting. Now, over time, some of them learned how to dig their own holes, and those holes got some depth to them. Now, if they wanted to lay more than one egg, they could create these offshoot tunnels, each ending in a little baby room. Now, around this time, and I mean that very loosely, flowering plants appeared. Before that, you'd get a fistful of fern on Valentine's Day. With the flowers came pollen. Quite
Wait,
nutritious. Proteins,
is that
lipids,
a bee or a
sugars.
wasp?
Now, some wasps developed a taste for
I'm guessing
pollen.
it's wasp.
Maybe because the insects they were catching were covered with it. And now, instead of insects, they would pack their little baby rooms full of pollen. Some of these became today's pollen wasps. And some of them became the first bees. Hi, I'm Zay Frank. Jerry, the camera's not pointed right. Hi, I'm Zay Frank.
Get it right,
Instead of
Jerry.
doing
Come on.
sponsorships,
It's
these
been years
videos
now.
are now member-supported. If you like them, please consider joining me at patreon.com/truefacts. You'll see how these episodes are made and watch a grown man make dick jokes. From time to time, you can even help me write things. But
Creepy
more
days,
importantly, you're helping fund natural history and conservation videos. Also reminding you, there's a
Some of
channel
those I
called
haven't
True
watched
Facts Educational, where I edit the videos so that you can send them to your mom. I do. Where were we? Oh, right. So the bees went vegetarian and they're out there shoving their pollen into underground baby holes. Now, storing
Baby
any kind of
holes.
food underground has some challenges. To keep out the moisture and fungus and whatnot, some bees start lining their cells with saliva and other regurgitants. So far, the major
Regurgitants.
innovation in parenting is apparently shoving your baby in a plastic bag. But one of the biggest bummers of living underground is the ants. I mean, you've been at a picnic. Now, instead of your quinoa, imagine they're going after your babies. And you. So some bees went upstairs.
Whoa.
Plenty of holes now that you got flowering plants like trees. Come on, you want to explore that hole. Now, if you want to lay multiple eggs, you can't just dig a side tunnel. You gotta pack them in. Create a little series of rooms, each one with some food and larvae. Kind of sucks to be the first egg laid. You gotta wait for everyone else before you can get out. Anyway, now they're putting their babies in all sorts of crap. Find a snail shell, stuff a baby in it. And they get all creative with the materials too. Start using leaves and sap. And you know they're using the secretions too. Some of the wasps, they do their own version of this. Start building their little baby rooms on things like branches. Now, there's two important things that happen. One is, some of these mummies don't seal the room up right away, and they start feeding and guarding their larvae until they're a little further along. And the second thing is thought to have been the result of a bit of a timing hiccup. Imagine a mother who builds and lays eggs in a number of baby rooms, and it takes long enough that she's still working when the first child emerges. The first children often emerge smaller from being undernourished. Give mom a break, single working mother, so they hang around a bit before going off to start a new nest. Now let's say that their maternal instincts kick in a bit early, and so they start taking care of their sisters and maybe helping mom build some new rooms. So the idea is that slight changes to the timing of their development can lead to solitary insects becoming social insects, a family business. The stingless bees were thought to be the first ones to evolve this. With generations working together, you can start to go big, and some of these nests can have some complexity to them, with a sort of defensive labyrinth down at the bottom, and then plates or spirals of ordered baby rooms on top. It can start looking a bit similar to a honeybee comb. But these are more like little rounded pots put next to each other. But becoming social doesn't guarantee complexity.
It's not hexagon.
Honeybees became social, and their nests are a mess. No, it's not until you get to the honeybee and later the paper wasps, who use costly materials to make things that often hang down and have to support weight, before you start getting that insanely obsessive geometry. But how do they know how to do it? Do they have some idea of what it should look like? I mean, even a simple structure like this, let alone when thousands of them are collaborating on a nest. I mean, you know, statistically, there's got to be a few idiots in there. Well, for this, it's helpful to go over a concept called stigmergy. Stigmergy, terrible word, is the idea that a signal in the environment triggers some sort of behavioral response in the animal. I'm sure you know a bit about it because of the ants. When they're out exploring or looking for food, they lay down a little Hansel and Gretel breadcrumb trail as they go. But instead of breadcrumbs from the hand, it's pheromones from their butt region. You can see that one plop some down right there. You can think of it as...
Yeah, and if you, like, rub the path, like, rub the ground where an ant was going through, like, in between them, in between the ants, I mean, you can actually confuse them. Although, they can actually find their way back to the path again, if it's not too far. Yeah, I did experiments when I was a kid.
There's a butt perfume that fades over time. Now, when the next ant comes across these pheromones on the ground, it gets a signal to follow that trail. And the stronger that signal is, the more likely they are to do that. Now, this simple rule famously allows ants to find the shortest distance between their nest and a food source. At first, there's ants walking all over the place, but the ants that happen to follow the shorter path double back first and reinforce that route more quickly. which leads others to do the same. Now, when ants build their nests, they do something similar. This right here is the nest of the common black ant, Lasius niger. You can see the inside looks a bit like a problematic colonoscopy, but if you zoom out a bit, you can see there's some sense to it, sort of a multi-level condo. Now, to build these nests, each individual ant only has to follow a few simple rules. First, find a little pellet of dirt to pick up that is not covered in pheromones. Then add your pheromones to that pellet. Next, walk around until you find other pellets that do have pheromone on them. The more the better. Then drop your pellet on top of them. Next, if you find a pile of butt-stank pellets that's about as tall as you are, add your pellet up top but to the side. Using these rules, you can see that they build the supporting columns. And then as those side bridges start to join up, they're building the floor of the next level, on top of which they'll start building new columns on the next floor. As the nest grows bigger, ants start reusing pellets from the bottom to build the top. The pheromones down there have evaporated, and this means that the nest is like a constantly moving escalator, with layers on the bottom disappearing as new layers get added on top. But here's the crazy thing. If you look close at this scan of the hive, you'll see that there's connections between the floors. Now here's the thing, no one builds those. Instead, they're a natural byproduct of the somewhat random unevenness of the building process. These defects, called edge dislocation and screw dislocation, also happen when crystals grow, and you can see them form and create connectivity between the layers as the nest gets bigger. These also show up in termite nests. The point is that complex things can be built using simple patterns of stimulus and response. And some of the chaotic randomness of this can actually be beneficial. It's not just pheromones, by the way. A signal to do something can come from all sorts of things. A major signal for termites is humidity, which allows them to create massive structures which are ventilated and temperature controlled. So if you're looking for stigmergy, the trick is to find a specific signal that elicits a specific response. And one way to do that is to mess with an insect while it's building. For example, some potter wasps make little entrances to their
actually kind of looks scary.
The first stimulus is their hole. I'm like 12. Then there seems to be stimuli related to height and curvature and shape. And the science hippies figured this out by doing stuff like this. If they're building the straight part and you bury it part way, they'll keep building it until it's the right height. When it's the right height, that's the stimulus to start curving. But now, if they're building that curve and you bury it part way, they don't care about the height anymore. And they'll build that bell shape right into the ground. If you really want to mess with them, cut a hole in the top after they've finished, because that hole is back to the first stimulus. And instead of patching it up, they'll build a whole new funnel. So you can make sort of decision tree flowcharts out of this stuff. Kind of makes it more fun to watch a paper wasp queen start a new nest. Work on the angles of your base until it forms the stimulus to start building the stalk. This stalk, by the way,
she looks beautiful. It's really pretty.
A line of defense, literally. When the stalk's the right length, you build a sort of flat surface that provides the backing for your first cells. Now, in this case, the cells start off as circular tubes.
Sturdy.
Then she sticks her head in there and applies pressure to form the flat walls of adjoining cells. So the outermost cells
can get how
rounded side
cool she
lay an egg
looks.
in one of them, and pretty soon you've got some help. But now, as the nest grows and you got more workers, things get a bit more complex. Depending on where the wasp lands, you've got all sorts of shapes.
That stalk up there is really strong.
Build a wall higher, start a new cell, stick your head in one and shape it. If you give wasps a new color of paper each day to work with, you can see they're building all over the place. It's not like one starts a cell and sees it through. They build based on the task at hand wherever they are. As you can see with inmate number 7.
Inmate number 7.
Stimuli aren't just on-off switches. You can think of them more like urges, which have different strengths. So depending on the shape
I know they'd probably kill me, but they look so cool.
Doing a particular thing. For example, the probability that a wasp will start a new cell seems to have to do with how many inward corners they come across. In the first one, you got a corner, but it's outward facing, 0 probability. Next one, you got one inward corner, goes up to 20%. You get it, and by the time you get to the last one, it's almost guaranteed that they're going to start a new cell there. But a different species may have instincts with different probabilities. And you can run simulations that show how you get different nest architectures from them. Now at this point, you might be like, all right, I get it. Honeybees and their hexagons, they do it the same way as these wasps, right? Set of pattern responses triggered by stimuli. You fart out a honeycomb. And this may be true, but it doesn't stop science hippies from challenging this idea. One reason for this is how well honeybees do when things get wonky. Out in nature, they build their honeycombs in all sorts of places, which means you're not always building in nice flat sheets. Science hippies got them to build this sheet just by rotating the hive every few days, changing the direction of gravity. And what's more is that the hexagons they build aren't always the same size. The ones they make for male babies are slightly bigger. So with things like curvature and size differences, you can't really do that nice even tiling we saw in the beginning. In fact, when you look closely at a honeycomb, it's not all hexagons. Look at that, you got squares, pentagons, whatever the 7-sided ones are called, and even an octagon. And you can especially find these anomalies when combs merge. Those hexagons just don't line up. And that's the thing, honeybees seem to be great at taking lemons and making lemonade. I mean, they have the honey. Kill me. For example, you can get them to start building off of templates of wax. In this template here, the hexagons were just the right size. But if you start them off with hexagons that are either too small or too large, they find ingenious ways of transitioning them to the right size. So one argument is that if this was purely stigmergy, you'd have to have a ridiculous amount of rule sets to deal with all the things that the bees encounter. So maybe there's something else going on. Maybe they have a fuzzy in mind, or there's something to do with physics, like those termite ramps.
So fuzzy.
One idea was that if you heat wax up, it acts like a liquid, and maybe that mathematical purity emerges from physical forces like surface tension, much like how soap bubbles form geometric patterns. But hives don't seem to get hot enough for that to work. Another thought is that they're just building round tubes, but neighboring bees pushing walls against each other eventually finds a geometric equilibrium.
It's really cramped.
When you look at some of these bees start building, it certainly can seem like they're making hexagons. And the stigmergists might say, while smoking a pipe, I'm thinking like in a rocking chair in Provence, keep looking, the bees don't need anything to do these magic tricks except for some simple rules. Also a shitload of flowers, you need those. Oh, and that belly button that makes wax thing. I mean, it'd be pretty cool to have that. But in humans, it'd probably come from our ear holes, which would suck. Hey, Dale, is your wax ready? What? I said, is your wax ready? Yeah, I did my taxes already. And that's the sort of comedy writing gold you'll get to witness if you join my Patreon. Remember, supported dad
I'll be able to hear. It's fun. It's fun 5. I forgot the song, the words of the song. Oh, that was so interesting. I can't get over how cool some of those were. Those, like the wasps. I know they probably try to kill me, but they look so cool. Anyways, if you like my reaction, hit the like and subscribe. Drop a comment down below for any suggestions for future reactions. And I'll see you in the next video. Bye.